Hi, I'm Simon Smart, a consultant aerodynamicist working for Scott on the development of the Plasma 3. The development process started with the Plasma 2, which already has some very unique and interesting aerodynamic features. We use CFD and some unique wind tunnel development techniques to optimise the aerodynamic surfaces and reduce the drag of the frame in all areas. Our aim is to design the fastest bike in the world in time for Team Columbia to use in the major tours in 2009. I'm working very closely with the Scott composite engineer Cyril Berleur. He is responsible for taking the wind tunnel concept through to reality, concentrating on the structural issues, the design of the moulds and the manufacture. Lars Teutenberg, the technical manager of Team Columbia, has also been heavily involved in the project, bringing in his invaluable experience and technical feedback from the pro team. The design team first met in 2008, where we agreed upon the performance specification for the Plasma 3. This included the frame geometry, sizing, structural and practical issues. The Plasma 2 has some unique and original features which make sense aerodynamically. This provided a good starting point to develop the Plasma 3. Initially, I resurfaced the whole frame in CAD based upon my experience in aerodynamics, and then we used CFD and other analytical techniques to validate various potential solutions. At the same time, the first concepts were passed back to Scott engineers so that they could make sure that we could still achieve the structural and practical objectives. Moving on to the full-size wind tunnel testing, the wind tunnel program was split into 2 tests so that we could come away from the first test with new data and then repeat the whole process all over again. This is what we call iterative development in the race car industry. To achieve acceptable accuracy, all development parts are manufactured using a rapid prototype process called SLA. The frame is modular so that individual surfaces can be changed step by step during the wind tunnel test. As you can see, each one of these parts can be interchanged and comparative runs are then made in the wind tunnel to assess the performance. Our final solution was the culmination of over 300 test runs and almost as many parts. It's also imperative that you model the real-world conditions in the wind tunnel. The goal of this project is to design the fastest time trial bike in the world whilst retaining some of the great features of the Plasma 2.